Okay, good afternoon. My name is Mr. Hamusawasi from the Chemistry Center, and this afternoon we'll be looking at a topic, and the topic before us this afternoon is the mole concept. So, what is a mole? We say a mole is simply a unit of measurement in chemistry. Mole is a unit of measurement in chemistry. So I put it this way, that the same way foodstuffs like garri, rice, and beans are measured in the market using module, is the same way chemical substances are measured in moles. Now, what do I mean by this? Let's take a look at this picture on this slide. We have two elements there. We have carbon and we have copper. Now, carbon 12, or let me put 12 grams of carbon 12 is the standard we are using. So I want you all to note that 12 grams of carbon 12, and 12 grams of carbon 12 is said to contain 6.02 times 10 raised to power 23 atoms. So 6.02 times 10 raised to power 23 atoms. Let's take note of that. Now, it is believed that the amount of any other substance that will contain the same amount of entities as we have here is said to be 1 mole. Now, which means that the amount of copper that will contain 6.02 times 10 raised to power 23 atoms is 1 mole of copper. Now, I can change this. I can replace this with any element. I may put sodium. Now, the amount of sodium that will contain this particular number of atoms is said to be 1 mole of sodium. If I replace it with calcium, the amount of calcium that will contain this particular number of atoms is said to be 1 mole of calcium. So by definition now we say that a mole is defined as the quantity of any substance that will contain the same number of entities as we have in 12 grams of carbon 12. Now, it is very important we take good note of all these things that I've underlined. So that's that about the definition of a mole, which is very, very important for us to know, because these questions are very, very germane in WASC. Now, let's look at how we can express moles. Moles are expressed in 4 ways, and the very first one is that we can express our mole. We can express mole in terms of the formula. We can express mole in terms of relative molecular mass. We can express mole in terms of molar volume, that's talking about gases. And we can as well express our mole in terms of Avogadro's number. So we'll be picking this one after the other. So I would like each and every one of us to get a pen and papers and start to put something down. Now let's take a look at the first one. The first one is talking about moles in terms of formula. It is given that the formula for mole is the mass of the substance divided by its molar mass. This is one formula that every student every student has at the tip of their fingers. So we say mole equals to mass over molar mass. And let's look at how this is applied. Take a look at this question. This question says calculate the number of moles of substance present in 40 grams of potassium hydroxide. You've been given that potassium, that is the relative atomic mass of potassium, is 39, that of oxygen is 16, and that of hydrogen is 1. So, how do we go about this? Next is write the formula of the substance, which is KOH. In some instances, the examiner will give you the formula, which will, to a great extent, would have reduced the chances of errors, as I will put it. But for students who don't know how to write chemical formulae, this is the very, very good time the very best time for you to learn all these things. So the formula of potassium hydroxide is KOH. Now, we have been given 40 grams. The 40 grams given in the question is the mass. Now, all I need to find my mole is look out for the molar mass. And how do I calculate the molar mass of potassium hydroxide? All I need to do is, with regards to the atoms given in the formula. I have potassium, 1 potassium, which is 39. I have 1 oxygen, which is 16, and I also have 1 hydrogen, which is 1. By the time I put all this together, I have 56 grams, and the unit for molar mass is grams per mole. So I move ahead to substitute in the equation, and by the time I substitute, I have mole equals to molar mass. The mass as given is 40 grams, then the molar mass as calculated is 56, so I have 40 over 56, and I have my mole to be 0.714 mole. Now it is very important for students that will be writing WASC that every final answer must be in 3 significant figures, so that's why I have my answer as 0.714. Go ahead to look at the second example, still under mole in terms of formula, and that is calculate the number of moles of substance present in 7 grams of nitrogen gas. You've been given that the relative atomic mass of nitrogen is 14. So like I said earlier, the first thing you do is write the formula of the substance. Nitrogen gas is a diatomic gas, so it is written as N2. That is the very first thing to do. Now going on, it has been given, I said the given mass in the question is 7 grams, which we can attest to. Yeah, so the molar mass of nitrogen is 2 times 14, that is 1 atom of nitrogen is 14, and to calculate for the 2 atoms in the molecule of nitrogen gas, so I have 2 times 4, which is 28. So I move on to substitute into the equation, and I have 7 over 28, so it's just direct substitution. I have 7 over 28, and my answer becomes 0.25 moles. As well, you can still see that my final answer is in 3 significant figures. So I move on to the second one, that is the mole in terms of relative molecular mass or relative atomic mass, and I'm going to break this down to you. When we talk about an atom, when you talk about an atom, then I use relative atomic mass. And when I talk about a molecule, I talk about relative molecular mass. So this implies that 1 mole of sodium equals 23. This will always be given in the question. You don't need to waste too much time on that. 1 mole of oxygen gas. Oxygen gas is a diatomic gas. So in the question you'll be given 16. So all you need to do is that, since if 1 atom of oxygen is 16, then the 2 atoms present will be 16 times, which is 32. Then 1 mole of hydrogen gas will be 1 times 2, which is 2 grams. Then I said that 1 mole of sodium hydroxide, like we calculated earlier on, will be 23 plus 16 plus 1, which is 40. All these values will be given in the question. So note, as I said that the relative atomic masses of the elements are always given in exams. So all you need to do is calculate for the molecule, as I have done for sodium hydroxide. So it's a very simple thing to note. All you just need is pay critical attention to every detail in the question. Now let's look at how this is applied in exam situation. Calculate the number of moles of substance present in 4 grams of sodium hydroxide. Now this question has given us the formula of sodium hydroxide, and it is given as NaOH. So what do? I go on to say, recall molar mass of sodium hydroxide is 40 grams per mole. I believe we all still know how to calculate that. And if 1 mole of sodium hydroxide is 40, that is according to already, this is settled. We all know that 1 mole of any substance equals the relative molecular mass of the substance. So 1 mole of this equals the relative molecular mass, which is 40. So the question now is what will be the mass of, what will be how many moles, that's calculate the number of moles, how many moles will be present in 4 grams. Now it is very, very important to know that when we are, because we'll be using cross multiplication often. So what we do is that take a look at the unit on the right hand side. They must be the same. I have mole and mole, and by the time I take a look at the unit on the left hand side, you still know that they are the same, which is grams and gram. So now I can cross multiply. By the time I cross multiply, I have x times 40 equals to 1 times 4, and that becomes 40x equals 4. By the time I divide through by 40, I have x equals to 4 over 40, and my x equals to 0.100 mole. As usual, my answer is still in 3 significant figures. So I look at, in terms of Avogadro's number, Avogadro's number is the number of particles found in 1 mole of a substance. I want you to underline that 1 mole of a substance, as we have said earlier, 1 mole of a substance contains Avogadro's number of particles. 1 mole of a substance contains Avogadro's number of particles. And like as we pointed out in the definition of mole, we said it is the number of atoms that we have in 12 grams of carbon 12. Carbon 12 is a very good standard which every student or every scientist must know. So this is experimentally determined to be 6.022 times 10 raised to the power 23 particles. Now let's look at how this is applied. It means that 1 mole of hydrogen gas will contain 6.02 times 10 raised to the power 23 molecules. 1 mole of sodium metal will contain 6.02 times 10 raised to the power 23 atoms. 1 mole of CO2 will contain 6.0 times 10 raised to the power 23 molecules. 1 mole of chloride ion will contain 6.02 times 10 raised to the power 23 ions. So how is this applied in calculations? Let's look at this example. Calculate the number of atoms present in 3 moles of calcium. Calculate the number of atoms present in 3 moles of calcium. So all I need to do is just come here and say 1 mole of calcium will contain the Avogadro's number of atom. At least we know that from the previous slide. That is 1 mole of any substance contains the Avogadro's number of particles. Now the particle we are talking about, as stated in the question, is atoms. So we are looking at, so I just come here to say the 1 mole of the substance we're talking about is calcium. So I come down here and write 1 mole of calcium will contain the Avogadro's number of atoms. Now what is the question asking us to do? Calculate the number of atoms. So by the time I come here, I don't know the number of atoms that will be present in 3 moles. And very simple, I'll just put 3 moles of calcium, we have X. If that is the case, I cross multiply. And by the time I cross multiply, I have X multiplied by 1 equals to 3 multiplied by 6.02 times 10 raised to the power 23, and my answer becomes 1.80 times 10 raised to the power 24 atoms. So it is as simple as that. All that is required is, how do you make this statement? How do you make this statement? By the time you look at the question, look at what the question is talking about. The question has shown you number of atoms. So this is like telling you number of particles. And anytime you see something like this, know that we are talking about the Avogadro's number. And as well, you have your moles. So this is a relationship between mole and Avogadro's number, and that's why I just come here to write 1 mole of calcium equals the Avogadro's number. And now I can just come back to the question and say, oh, what's the question asking me to do? If I've established a relationship between mole and Avogadro's number, then the next thing is for me to come down here and say, therefore 3 moles will be X. That's because I'm actually looking for the number of atoms. So by the time I have this, then I have a very nice equation that I can cross multiply. And mind you, before you cross multiply, the the unit on the right hand side must be the same, must be equal, and the unit on the left hand side as well must be equal. So that's why I arrive at that. So let's look at another example. Calculate the mass of substance present in these molecules of H2SO4. Now, if we take a closer look at this is a little bit dicey. I'm looking at mass of the substance. The substance in question is H2SO4. Remember, mass is measured in grams. Mass is measured in grams. So let us note that for now. So I'm talking about mass in relationship to Avogadro's number. Mass in relationship to Avogadro's number. So what do? I just come and recall the molar mass of H2SO4 is this, and I have this. I believe everybody can calculate this, so I have 98 grams per mole. So note, we found the molar mass of H2SO4 because the question relates mass to number of molecules. So we still believe that 1 mole of H2SO4, that is 1 mole of any substance, equals the Avogadro's number of particles. The substance H2SO4, the particles is number of molecules. So I have this. But since the question is talking about mass, I can't work with mole. So I need to change my 1 mole to mass. Now, what is 1 mole of H2SO4? That is exactly what we mean by molar mass. So the mass of 1 mole is 98 grams. So I just changed this whole statement to 98 grams of H2SO4. We contain 6.02, and we have it like that. So I go ahead to look at what the question is asking me. The question is calculate the mass of substance. So I don't know the mass. So X gram will be present in this. So by the time I cross multiply, I have this, and punch that on a calculator, you have 392 grams, which is your answer. So what about in terms of molar volume of gases? It has been deduced that at standard temperature and pressure, I know most of us already must have heard of the STP. At standard temperature and pressure, 1 mole of any gas occupies 22.4 dm³. So this is used when the question is relating the volume, is relating mole to volume of gas. So let us look at this picture. We see that we can see in this picture 1 mole of hydrogen gas contains 22.4 dm³. 1 mole of oxygen gas contains 22.4 dm³. 1 mole of nitrogen gas contains 22.4 dm³. Please note that this only applies to gases, and you can only use it when a question is relating volume to mole. So we have, let's look at how this applied. A good example is this. Calculate the volume occupied by 3 moles of carbon 4 oxide. This is a very straightforward question, very simple. So I have, if 1 mole of carbon 4 oxide occupies 22.4 dm³, but I will just come back to the question and say, oh, the 3 moles of CO2 air will be occupying X. And by the time I cross multiply, I have this. X times 1 equals to 3 times 22.4. And I have my answer to be 67.2 dm³. Now, I would like my students, I would like everyone to note that everything that I've solved, I have taken the pain to show the steps. So in your exam in WASC, each step will be accorded a particular mark. So it is very important that you don't skip anything. Make sure you write out everything and you punch your calculator correctly to reveal the right answers. So on your own, you can do this. You can calculate, you can pause this and calculate the volume that will be occupied by 10 grams of hydrogen gas. Hydrogen is the relative atomic mass of hydrogen is 1. So thank you for your time. Try to subscribe to our YouTube channels as more videos will be revealed. Thank you, everyone.